So now in this video I am talking about some basic concepts of EDC, that is electronic devices and circuits. So in the solid state devices, that is in semiconductor material and in metal and also metal, so there are some key points or definition here. So first one is resistivity. In basic electronics, what is resistivity? Resistivity is defined and the symbolic representation of this with rho. And what is different? This is the specific resistance of the material unit for lambda. So this is the specific resistance of the material. So what is resistivity? The formula of resistivity is this is the when the resistance R equals to rho into L, that is the length of the material divided by the area, that is cross section area. So R is the resistance, rho is the resistivity into this. So this is the formula. And what is resistivity? The specific resistance of the material. The specific resistance of the material. The unit of rho is ohm, rho centimeter. Rho centimeter. Ohm centimeter. Ohm, this is the ohm and this is centimeter, or ohm meter. This is the unit of resistivity. And this is the main formula you can remember, that is how we define rho. Rho equals to R into A, that is cross section area, by length of the material. Now, so for intrinsic semiconductor, you need to remember this point, that is intrinsic semiconductor. For intrinsic semiconductor, that is pure semiconductor, R, that is NTC of R. As we previously discussed, that is what is NTC? Negative temperature coefficient. That means R decreases with T increases. So as well as here also rho, obviously R is decreasing, so rho is only depend on R on rho is, this is the relation. So from this we can get this point. Now proportional to the R. So similarly, obviously rho is decreasing with temperature. So this is denoted as NTC. So now after resistivity, another is conductivity of semiconductor. What is the conductivity? It is denoted at sigma. Conductivity of semiconductor means this is the inverse of resistivity. Conductivity meaning the inverse of resistivity. Conductivity denotes the current carrying capacity. Current carrying capacity of a material. How much current it could be carry, so that is the capacity of the current carrying capacity of the material is known as conductivity. For conductivity is 1 by rho. Obviously, what is the unit of conductivity? Inverse of rho, that is mho per centimeter or mho per meter. So this is the conductivity, and conductivity is denoted as relationship, that is conductivity is a carrier concentration into magnitude of charge into mobility. What is mobility? If you don't know, then please check my video on mobility. So now what is carrier concentration? That is N or P, that is the carrier, how much majority carrier or minority carrier are present in any material or semiconductor devices, into magnitude of charge, that is the how much charge it can be hold, that is Q. So into mobility. This is the formula of the conductivity. This is, you need to remember. So now in conductivity, variation may be due to variation in carrier concentration, variation in mobility, or charge carrier. If three are changing, that is vary, then obviously conductivity is vary. So now for intrinsic semiconductor, this is the main point, that is in intrinsic semiconductor, conductivity is how much? Conductivity sigma equals to n. That means carrier concentration first we consider as the electron concentration for n into magnitude of charge, that is q, into mobility, that is mu n for electron. Now in material both are present, electrons and holes. So that why n q mu n for electrons and plus, so this is for electrons, and now plus for hole, that is hole concentration h into magnitude of charge, obviously q, into mobility of hole, that is mu p. So this is the for intrinsic semiconductor, that is pure semiconductor, sigma equals to nq mu n plus hq mu p. This is the formula to finding the conductivity. Now as temperature is increasing, that is if temperature is increasing, obviously temperature is increasing, then sigma is also increasing, because in this are changing, that is increasing, so mobility, magnitude of charge, and carrier concentration. So that's why mu is sigma is also changing. Here some another point is that some note, you can write some note, that is in intrinsic semiconductor, conductivity mainly depends on carrier concentration, only this part, because in intrinsic semiconductor this is only depend on carrier concentration, that is how much number of electrons or how much number of holes are present. And for metal you write down for metal what is the changing of conductivity, that is for metal sigma is reduces with temperature increasing. Why? Because for metal the sigma is only n q mu n. This is only n q and mu n. Here if temperature increasing, as we know mobility will decreases with temperature, so overall sigma will also decreasing. So this is the point for the conductivity. Now the next is current density. So next is current density, which is denoted as J. The current crossing per unit or cross-sectional area. What is the definition of current density? The current crossing per unit crossing per unit cross-sectional area. So in symbolic representation, J equals to, that is current density, current, that is I, per unit cross-sectional area, that means cross-sectional area. So area is meter square and I equals to ampere, so the unit of current density is ampere per meter square. So up to this the current density is all. Now there are current, that is two current. How? Number of current. There are in semiconductor device, there are two type of current. One is drift current. You write down your note, that means drift current, and another one is diffusion current. So now let's talk about what is drift current and what is diffusion current. In a semiconductor, this is the semiconductor, there are electrons, holes, these are present, electron holes, or we denote as positive, negative. So now in what is diffusion? First discuss about diffusion. Diffusion means spread. So now if there are non-uniformly, when excess carrier are created, we make as excess carrier, that is more electrons, holes we put into the semiconductor, or diffuse, then non-uniformly in a semiconductor, that is non-uniformly. Maybe somewhere the concentration is be more and somewhere the concentration is be low. So the electrons or holes, this carrier, are moving towards higher density to lower density or lower concentration. So higher concentration to lower concentration, the moving between holes and electrons are created some current in the semiconductor, are created current. So by this diffusion process, which are the producing by the current, which are producing the current, is known as diffusion current. What is diffusion current? So the electrons and holes are moving to higher concentration to lower concentration area when non-uniformly electrons and holes excess carrier are created on the semiconductor. So this is diffusion current. And what is drift current? Drift current means in an in a semiconductor, if you give the electric field, that is, if we put some electric field on the semiconductor, there is some field are producing. So for the field, that is E, there are some electrons, positive and negative ions, that means electrons and holes are moving. For moving the electrons and holes, there are producing some current also. So this current is known as drift current, which is produced by electric field. So up to this, the current are two concepts are clear. Now let's discuss about in the symbolic representation or in the equation of the diffusion current and drift current. So in diffusion current, the current density, that is J, for electrons, that is N, Jn diffusion, for that means diffusion current of electrons, diffusion current density of electrons, that is Jn diffusion, equals to obviously negative. Because first, why negative? That means electrons are moving to higher concentration to lower concentration. That means they are directed, the direction is opposite. So that's why for this direction, so by now the carrier gradient are here, that is Q. That is the charge of the carrier. That means the charge of electrons, we know that minus Q, because this is a negatively charged, into the diffusion constant, denoted as dN, diffusion constant for electrons, into the gradient of moving of the electrons concentration. That means according to the position, that is the x, d of x, changing the position or distance change according to the concentration of electrons, that is N, denoted for concentration. So dN by dx is the gradient of concentration changing to higher density, lower density, into the diffusion constant, that is dN, into the charge. Now overall negative for the inverse direction of moving charge carrier. Now this is what becomes, that is, this becomes Q dN to dN by dx. So this is become this. Now diffusion density of current density, diffusion current density for holes, what it becomes? That means again negative. Now again charge of the carrier, that is for hole, the charge of carrier is plus Q, that is positively charged hole, for P for hole, into diffusion constant, that means dP, into d of concentration change according to the position or distance, that means for hole, that is dP, concentration, hole concentration according to the distance change, that is dx. This is the gradient. So now this becomes negative Q dP to dP by dx. So this is the main equation of diffusion current density of holes and electrons. So this is very important and this is need to be remembered for mathematical problems. Now let's talk about what is the drift current, that is drift current density of electrons and holes. Drift current density of electrons, that is Jn drift. For electrons, this is Q, that is the charge of the carrier Q, into mu n, that is the mobility of electron, into n of n, that is the concentration of electrons, the whole electron concentration, into electric field. That means this is what? This is the conductivity. Conductivity multiplied by electric field becomes the density, current density of drift. Now Jp drift, that means whole current density of drift current density for the whole, equals to, obviously again, charge Q. There are no sign, that means no positive, no negative sign for electrons or holes. Both are only magnitude part. Drift means only magnitude parts. So that's why both are in positive. So Jp drift Q into mu P, that is mobility of holes, into P, that is concentration of holes, into electric field. So this is the drift current and for electrons, and drift current density for holes. Now what are the main current density of total current density of electrons and holes in a semiconductor? Just add them. This is equation 1, this is equation 2, and this is equation 3, and this is equation 4. Now what is the main current density? That is Jn. Current density of electron in a semiconductor equals to, obviously, Jn drift plus Jn diffusion. Similarly for hole, that is Jp, that is whole current density, equals to whole current density drift current, whole drift current density of holes, that is Jp drift plus Jp diffusion. That is equation 2 plus equation 4. Here equation 1 plus equation 3. If you calculate this, then you can get the expression of overall Jn and Jp, that is the current density. So up to this, the whole current and current density are to be clear in this video. Now in next topic is, the next topic is diffusion constant. Diffusion constant means diffusion constant is the formula, that is the denoted by D, equals to mobility into thermal voltage, that is Vt. So the formula is, now for electron what is becomes, for electrons, D denoted by Dn, that is the diffusion constant of electron, equals to mobility of electrons, that is mu n into Vt. And for hole, this, that is positively charged carrier, that is for hole, diffusion constant is D of P, equals to mu of P, that is mobility of hole, into V of T. So diffusion, this is, so now how diffusion constant are depend on the temperature, that is D, how depend on temperature. Now if we increase the temperature, so what happens? If we increase the temperature, obviously mu is decreasing and Vt is proportionally increasing. So how the relation among temperature in mobility and Vt, that is mobility and Vt, that is mu is proportionally T to the power minus n, and Vt depends on temperature, like Vt proportional to temperature. So if we multiply this, so what it becomes? then obviously temperature is decreases if dp will increases. That means d is, if d will increase, so this is depend on d into 1 by t. That means inversely proportional. That means if we increase the temperature, increase temperature, then d will decrease, because if we multiply this, obviously this is also negative. So temperature coefficient is negative. So dp is inversely proportional to the temperature. Diffusion constant decreases with temperature. dp means dd. That means diffusion constant. Diffusion constant. Now, if you need to remember the diffusion constant value for the IS examination. What is the unit of dp? Let's discuss the unit of mobility into unit of voltage. That means the unit becomes centimeter square per second. Centimeter square per second, because mobility is centimeter square by volt into second. That means into volt, that is Vt, volt. So volt cancel out, so it becomes centimeter square per second or meter square per second. This is the unit of diffusion constant, that is d. Now let's talk about the value of germanium and silicon, the dn and dp. The value of dn, that is electron diffusion constant for electron and diffusion constant for hole. Talk about the value of germanium and silicon. So this is the value of dn for germanium at T equals to 300 Kelvin. Both are calculated here. So at T equals to 300 Kelvin, the value of germanium of diffusion constant is 99 centimeter square per second, and dp of germanium is 47 centimeter square per second. 47. This is 99. Now for silicon, the value becomes of dn is 34 centimeter square per second, and for dp value is 13 centimeter square per second. You also check the value from your calculation, like what is the mobility, that is mu n for the germanium and mu n for the silicon, and put into the voltage Vt, that is 26 millivolt, that is 26 into 10 to the power minus 3 into the mobility values that I am discussed earlier on my videos. So you can check the values. So this is become 99, this 47, this 34, and this 13. So these are the value. And what is diffusion constant? Actually, this is the property of a material, that is property of associated with the property of diffusion. That is diffusion properties of material. Any property of material is known as the diffusion constant. This is the property. So another now after diffusion constant value, now new equation, that means new relationship between diffusion and mobility is known as Einstein equations. Let's discuss. Now what is said by Einstein equation? Einstein equation says that in a semiconductor we know that there is the diffusion constant equals to mobility into the thermal voltage. Now diffusion constant, Einstein said that the diffusion constant is dn for electrons divided by diffusion constant by holes, that is dp equals to mu n, that is mobility of electron by mobility of hole, that is mu p, equals to Vt. Obviously d by mu equals to Vt. So d by mu is constant for both the electrons. D by mu ratio obviously constant. That means as this is also written as like that, that is d by mu into Vt. As we know from this equation, we get d by mu equals to Vt. So dn by mu n, obviously this is constant term, that is d of p, that is, and mu of p, obviously this is equal, and this is equals to the thermal voltage, that is Vt. So now this is the Einstein equation, and that is d by mu is proportional to the temperature. That means it depends on a similar, because d is also changing and mu is also changing. That is, this is Vt, d by mu is equals to Vt. Obviously d by u proportional to the temperature, that is the Vt also depends only proportional to the temperature. So this ratio is proportional to the temperature. So the unit of mobility of diffusion constant is volt inverse. So now what is the mobility to, this is also called mobility to diffusion constant. Now why this is called, that is mu n by dn. If we inverse this, mu n by dn equals to mu p by dp. Obviously it is inverse, that is 1 by vt. So what is the unit of mobility constant to diffusion constant? Equals to 1 volt inverse. Volts inverse, because 1 by vt, so 1 by volt, that is volt inverse, is the unit of mobility constant to diffusion constant, or diffusion constant to mobility constant ratios unit is only volt. So these are the equation of Einstein equation. This is very important to for the mathematical problem solving. So now the unit of d by mu equals to volt. So this is the relation between the mobility and the diffusion, and also the thermal voltage. Up to this video ends. Now in the next video we'll discuss about some other concepts or topics. Thank you.